Welcome to This Explainer. Today, we are unpacking what I can only describe as a completely chaotic convergence. I'm talking about massive AI compute scaling, autonomous agent deployment, and brand new federal policy. May 2026 is, without a doubt, going to go down as a massive inflection point in tech history. It wasn't just, a month of isolated announcements or tiny product tweaks. No, this was the exact moment where the physical limits of hardware, the reality of how software operates, and the actual legal guardrails of our government literally all collided. So I really want you to think about this question. What actually happens when massive compute, autonomous agents, and new regulations all collide at once? Because think about it. How incredibly rare is it for physical hardware limits, operational software paradigms, and sweeping national regulations to undergo massive, tectonic shifts in the exact same 30-day window? It's practically unheard of. But that's what May 2026 was. It was the exact moment AI scaled up in 3 dimensions, all at once. We're looking at a fundamental shift in how AI gets its physical power, how it acts autonomously on our behalf, and how the law actually governs it. The ripple effects for builders, huge organizations, and, everyday users like us, they're absolutely monumental.
All right, let's dive right in and systematically unpack this 3-pillar convergence. We're going to cover scaling AI compute infrastructure, the Agentic AI shift, the new federal AI policy framework, and then we'll wrap up with a concrete developer action plan. Okay, Section 1, Scaling AI Compute Infrastructure, or as it's quickly becoming known, the Great Compute Land Grab.
Just look at that number, 300. Back in early May, Anthropic secured a completely staggering 300 megawatts of capacity at SpaceX's Colossus 1 data center. And to really wrap your head around the gravity of this, we've got to stop thinking of AI as just, invisible software floating in the cloud. It is a heavy, physical, industrial beast. 300 megawatts? That is roughly the sustained power draw of an entire mid-sized city neighborhood. We are talking dedicated substations, advanced liquid cooling, just an astronomical amount of raw electricity for a single compute cluster. You absolutely do not make an infrastructure play of this magnitude unless your internal projections are flashing red, telling you that traditional cloud computing is about to hit a brick wall.
And here is the immediate consequence of that massive power grab. Over 220,000 NVIDIA GPUs deployed right now. And listen, this isn't some comfortable little buffer they're saving for 2027 or 2028. No way. Anthropic is filling this massive cluster right this second to fight off severe degrading response times and absolute capacity limits. Why? Well, it comes down to the sheer intensity of autonomous coding tasks. When a dev uses Anthropic's Claude code service, they aren't just sending a cute little text prompt. The system fires off dozens of concurrent search, write, test, and compile loops all in the background. It just eats compute at an unprecedented rate. So this is a desperate land grab. In the AI race, if your model times out, developers are going to switch to your competitor in a heartbeat. They had to lock down this raw power in silicon just to survive the sheer demand.
Which brings us to a really massive underlying shift, moving away from traditional cloud intermediaries toward complete vertical integration. Relying on shared platforms like AWS or Google Cloud used to be the default, but AI labs are waking up to the fact that renting shared space leaves you incredibly vulnerable to bottlenecks. You're basically fighting for bandwidth and hardware with thousands of other companies. To survive, you have to vertically integrate. And we're seeing this survival tactic mirrored elsewhere too, like Elon Musk's staggering $20 billion Terafab initiative. They're tapping Intel's 14A process technology to centralize US chip fabrication, memory, and packaging completely in-house. The biggest players are literally rewiring the global tech supply chain so they never have to rely on middlemen again.
So, moving from the hardware layer up to the software layer. Section 2, the Agentic AI shift, and how we are completely reimagining supervision.
Okay, what we're talking about here is arguably the single most important conceptual shift in the entire AI industry right now. We are moving from human in the loop to human on the loop. Let's break that down with a real-world example. Human in the loop is when an AI drafts an email for you, but the system stops and literally gates the action until you physically click send. It needs your direct approval. But as compute scales up, that human element, it becomes a massive bottleneck. So, enter human on the loop. This is where the system just runs continuously. Imagine an AI agent that monitors your inbox, drafts replies, negotiates vendor deals, and signs contracts, all while you are fast asleep. You just wake up, sip your coffee, and review a summary log of what it did. You aren't approving every little action anymore. You're just supervising this autonomous engine. And let me tell you, the difference isn't just philosophical. It is completely rewiring the economy of digital work.
But, and this is a big but, that shift introduces a frankly terrifying new reality.
because the failure mode is no longer, oops, the user clicked approve on a bad draft. The new failure mode is, hey, the system ran autonomously for 3 hours, completely hallucinated a command, and deleted our entire production database before anyone even noticed. Ouch, right? Because of this, these secure redundancy mechanisms that Forbes flagged are now absolute engineering necessities. You need monitoring interfaces and anomaly detection to instantly flag if an agent starts acting weird. You desperately need rollback mechanisms, meaning you can just hit undo and revert your systems to a snapshot from before the AI went rogue, and you absolutely must build strict confinement boundaries, basically sandboxes that ensure even if an agent totally hallucinates, it physically cannot touch your core secure infrastructure. You just can't build autonomous AI without these safety nets anymore.
All right, let's pivot and see how this all crashes into legal reality. Section 3, the Federal AI Policy Framework. Specifically, we're looking at the National Policy Framework for Artificial Intelligence published by the Trump administration in March 2026. And if we look strictly at the mechanics of this policy, the primary objective is preemption. Now, this is a crucial legal doctrine. The central headache for businesses over the last few years has been the threat of state-by-state fragmentation. Imagine trying to build a complex autonomous agent, right? It's perfectly legal to deploy in Texas, but suddenly it violates some algorithmic compliance law in California, and oh, it requires a totally different data storage architecture in New York. It's a total compliance nightmare that just kills innovation. So the federal government is stepping in to create a baseline national standard that explicitly overrides those state-level laws. For builders and national companies, this unified framework, regardless of how strict the specific rules actually end up being, is a massive operational relief. It means you finally only have to build to one single rule book.
But alongside that federal preemption, regulators are officially defining a massive legal threat, and it's called the black box liability zone. Now, this isn't just about getting some bad PR if your AI makes a silly mistake. We are talking about massive, catastrophic lawsuits. If you deploy a human-on-the-loop system and it independently makes a decision that causes financial loss or discriminates against the user and you cannot produce a legally defensible log showing exactly why the neural net made that choice, your company is entirely liable. You can't just stand in front of a judge and say, well, the AI did it and we have no idea why. No way. If your system lacks a clear, transparent audit trail for its autonomous actions, you are operating squarely inside this liability zone. Audit trails aren't just a nice-to-have for debugging anymore, they are literally a legally mandated defense mechanism.
So now that we've covered the converging forces of 300-megawatt compute clusters, always-on autonomous agents, and federal preemption, what do we actually do about it? Section 4, the Developer Action Plan. Let's get into what you should be doing right now.
Let's treat this like a genuine strategy briefing, depending on what you actually do in the industry. First up, the API users. You have got to design for capacity variation. Do not just assume infinite availability because Anthropic bought a bunch of GPUs. Implement exponential backoffs and intelligent retry logic into your apps right away. Second, to the architecture evaluators who are building these new agentic workflows, build deep observability and state-saving audit trails right this second. Seriously, if you don't, you are walking your company straight into that black box liability zone we just talked about. Third, the policy trackers. Stop wasting your cycles stressing over piecemeal state laws. Focus entirely on the text of the new federal preemption standards, because that is the new baseline that's going to invalidate all that localized compliance work. And finally, the infrastructure followers. As massive players like Musk build vertical hardware stacks like Terafab, avoid hard-coding your software dependencies to unproven specific hardware. Keep your abstraction layers. The physical infrastructure is just moving way too fast right now to get permanently locked in.
May 2026 was not a moment of neat resolution. Not at all. It was a chaotic peak of massive, simultaneous pressures across hardware, software, and the law. The compute is fully plugged in, the autonomous agents are literally awake and running in the background, and the federal laws are finally ink on paper. Which leaves us with one vital question to ponder. Can our regulatory and safety frameworks possibly keep pace as these autonomous systems scale globally? The environment has permanently shifted, folks, and the only variable left is how quickly you adapt. Thank you so much for joining me for this explainer, and I highly encourage you to go take a close look at your own systems today.